All right, it looks like we've got a lot of people joining us today. We want to thank everyone for spending time with us as we talk about embedding sensors in products. Today we have two featured guests with speaking for Interface. First, we have Randy White, who represents our Oem Solutions line and is a great resource to talk about some of the applications and products that we use for Oem Solutions throughout the world. And then, of course, we have our resident expert here, Brian Peters. Brian has been with Interface for a long time, seen many of these OEM solutions put to use and used by many of our top customers today. So we want to thank you for joining. Again, everybody is muted during this presentation. However, the chat feature is open. If you have any questions, we'll address those at the end. This will be recorded and we'll be sharing it with everyone after the event, so you have it as a reference, and also be posting it on our YouTube channel. So to kick things off, let's get started. Randy?
All right, thanks, Jamie, and thanks the marketing department for kicking off our first webinar of the year. As many of you know, that we've got a lot of these recorded webinars out there on the website, so please follow us and our YouTube channel as well. So thanks everyone for joining. I am Randy White. I am the Interface OEM New Business Development Manager. So I've came over from our sales department recently, and basically just trying to get us going on the OEM side of things, more from a sales perspective, and bringing the communication from sales to production, engineering, bringing everybody together. So as you'll see in the presentation today, we have a dedicated team for OEM Solutions. So we'll be introducing that as we move farther along. So we'll kick it off. Topics of discussions today. I'll handle the Interface OEM Solutions portion, and then I'll hand it over to Brian Peters to basically go over how to get started and dialing in your specifications and requirements. I'll take over the process and the common sensors used in the typical applications, along with trends, and then we'll kind of split up the application notes and use cases. So, and as Jamie mentioned, you'll be muted throughout the presentation, but during our frequently asked questions section, once we get done with that, then we can open up the mics to answer any questions once we finish up. So, okay, let's get started. So some of our key takeaways that we want to make sure that you guys capture today is Interface is not just a test and measurement company. So OEM is a big part of our business, everyday part of the business, and it's been that way for a long time. So we just want to make sure that everybody understands that. And with our OEM sensing team that we've got put together, dedicated, we have had much more success now in not only the U.S. market, but also our international market. And all this is basically based off of teamwork. So the importance of that. So we have been, we've got 50 years of experience providing custom engineered and manufactured solutions used by OEMs around the world. OEM comprises over 30% of our business. So 50 years of experience with over 30% of our business. We've seen a lot of applications, and we've worked with a lot of customers out there. So we're bringing a lot of experience to the team. Our products are designed to meet the customer's unique specifications and requirements. So it's not just standard load cells. It's definitely custom load cells, combining different types of sensors together. Ultimately, we are, just basically solving the customer's problem, and we've got many ways to get creative to do that. We do incorporate stocking and supply management as part of our full service solutions. Obviously, partnering is a big part of what we're going to be talking about today. So the more information we have in the early stages of this, it basically equates to success for not only us, but also for you, the customers. And we do designate specific part numbers for each solution or each custom device that we come up with. So these part numbers are basically exclusive to the customer. So these aren't just your standard part numbers out there exposed to the rest of the world. Next. So we define our OEM solutions portion. Really ultimately looking for a solution to our customers' problems. These typically start with standard design and lead to modified or custom solutions. So we'll take the different sensor types, load cells and miniature load cells, and load buttons, load pins, torque, multi-axis sensors, existing components. We can take components and basically transducerize them, convert them into a load cell. We'll get a little bit deeper into that farther into the presentation, but strategic partnership and engineering support is the key to success. Is the most important part of this, and it's not only our part, our engineering support, but it's also your engineering support. We get the engineering groups work together. So we've got the expertise on force measurement side. You guys have the expertise on your application and your expectations, and together we can kind of work through that for a successful solution. And we consider high volume, 1,000 to 50,000 pieces, per year. So that's, those big quantities. We are more than capable of handling those. And it's not 1,000 is not our cutoff by no means. So we're more than capable of handling smaller quantities as well. And next. Our capabilities. Products requiring sensor technology and components. Sensors utilized to measure force, weight, and torque. And we help you in the management and test and measurement of your processes and protocols, precision performance requirements and testing. I mentioned earlier the instrumenting of the customer components. If you don't have the room to actually insert a load cell into your application, then we're more than capable of actually taking a component that's in line and transducerizing that, basically instrumenting strain gauges to the component and turning it into an active component or a feedback sensor for you in your application. And with our in-depth MPI process, new product introduction, we've created this process, and it's based off of our OEM best practices. So over the years, over the applications, over the solutions, we've put this together. So this really helps the communication and the partnering with our customers. And we can't emphasize enough that we really need to, get involved on the very front end of this, of the process of the program, so we can obviously work together with you guys to be as successful as possible. Next. Okay, the different types of products that we commonly see in here. In some of these OEM markets, medical devices, we've got fluid management or surgical robotic assistance. A lot of our miniature load cells, bending beams, miniature beams, MBPs, MBIs, load buttons, commonly used sensors in these. A lot of these, as you'll see as we go through this, we've got some application notes to review in the end, and we'll cover the different types of sensors there as well. But machines and equipment, so a lot of torque sensors used in these, multi-axis, along with your standard load cells or modified, customized in these particular things, whether it's riveting, CNC machines, or even your robotic equipment or booms and lifts, lifting devices. You'll see our load buttons and load cells used in those applications. Industrial automation. Industry 4.0, that's right. That's a big one, a big buzzword that everybody's looking into these days. Industrial automation has been growing over the years, but the smarter, the more sensors that they're incorporating in those things, they just continue to get smarter and smarter. The more sensors that they do, actually, it's just kind of a domino effect. They're needing additional sensors to continue to improve those efficiencies and automations. Robotics, another big market for sensor feedback. And we're experiencing the multi-axis is very common in those particular applications, but also customization as well. Material and extraction pumps in the energy market, right? There's pumps out there used every day. So our torque sensors are pretty popular, and that's a good targets to go after. Material extraction, so when they're pulling the materials out of the stuff, yeah, they're having it separated. And they're using the load cells for, weights and measurements and, force feedback there as well. Weighing and monitoring. Yeah. Constantly, force sensors, that's pretty common in that from the weighing standpoint, and or just monitoring the process as it's going through for that weight feedback or, force feedback. So smart agriculture, another up and coming one that, right, industrial automation is obviously, trying to get, these manufacturing facilities more efficient. Well, same thing with farming, right? They're trying to get that as efficient as possible. And it's crazy what they're doing with the equipment and machines out there today. So many of our sensors are used in this market, multi-axis, torque, and load cells. Vehicles and components of the vehicles, the boom lifts and things like that, load pins for force feedback, for sensing and lifting, just the autonomous vehicles, a lot of that stuff, the trucks and stuff like that, a lot of weighing feedback from that standpoint, electronics, braking and monitoring systems in there. Okay, next. Partnering for success. Yeah, this is the big one here. For both of us to be successful. The benefits of partnering with Interface, obviously the experience, the 50+ years, over 30% of our business is Oem Solutions. You combine that with all the applications, all the customers, all the products out there. So yeah, we definitely bring that to the team. And when we partner, we are an extension of your team. So we definitely want to work with your engineering group. You guys are the experts on your products, and we're the experts on ours. So bringing those teams together is extremely important. Expertise in engineering, Oem Solutions. So we definitely bring that. We've got, once again, 50 years plus 30% of our business. We've got a lot of experience in that segment there. Our build capacities and capabilities. We've got a dedicated team that we've got set up for Oem. So along with that dedicated team, we've got a dedicated location, a dedicated line for the high volume products. Manufactured in the U.S. Yep, right here in Scottsdale, Arizona. So we've got support here in the U.S. Not only sales support, obviously engineering and manufacturing and supply chain. So we handle it all from here. Obviously, we talked about the dedicated team. We do have a manufacturing line dedicated to our high volume products, along with engineering techs, design engineers, and product management. We'll go through that a little bit deeper moving on. Trusted partner with a winning track record. Yeah, 30% of our business. So we've obviously been successful doing this. And highly customized designs, balancing costs and capabilities. So that MPI process, new product introduction that we discussed, that is so important when we come across and get these wins, is that we're trying to look at everything from the front end all the way to production times. So supply chain is a big part of that, manufacturing a big part of that. So we're trying to automate as much as we can and basically design the parts for manufacturability. So next. All right, I'll hand it over to Brian Peters, how to get started.
All right, thanks, Randy. Getting some feedback from somebody. There we go. Okay, so as Randy mentioned, a lot of this is around teamwork. Interface really wants to be an extension of your existing resources that you have in-house. Early engagement is going to set everyone up for success. We really prefer to be in early in the project to be able to understand exactly the problem case. And as a result of that, we'll be able to more efficiently design the best solution for you and for us on both sides. So again, lots of dedicated resources, as Randy's already highlighted, dedicated team to support. We know that OEM is a long-term strategy. It's a lot different than just selling a single sensor component. It really is about establishing foundation, the partnership, of course, to be able to support long-term. A lot of sustainment involved there. Next. So it's collaborative. The earlier we can get involved, the better we can understand the problem. We can look outside just the sensor. Oftentimes with OEM, of course, we're going into another machine, we're going into a system, and how our sensing capability or the measurement interacts with the rest of the system often has a large impact on overall success. So again, early engagement and collaboration, I should say, will drive the best efficiency for overall project and long-term project success. So please, we have expertise. We've seen a lot of applications. We've seen a lot of different use cases, and we've certainly supported many different solutions. So we want to make sure everyone's well aware we've got dedicated resources, and we want to have those resources available to assist. So at OEM, it's a team sport from the beginning all the way through product initial prototype launch, validation, approval, and of course, sustainment, more importantly, from there on forward. Next. All right, dialing in on specifications and requirements. Oftentimes, customers will come to us in a bit of a bubble. We don't get to see really what's going on. They may say, we need this part to give us a price for these quantities. The best way to achieve success is to really dive in and understand what does the big picture look like. Basic questions, what are you measuring? And more importantly, why are you measuring this, right? What about the signal? How do you plan to connect to the sensor? What kind of signal do you need? Oftentimes, capacity is assumed to be known and to be an easy assessment. In reality, properly sizing a sensor is much more about understanding what is the actual measurement range you're looking for, as well as what are the potential loading conditions around that sensor. Want to make sure that we ensure success and maximize that measurement that you're trying to take. Then on the physical front, what does the envelope look like? And because, again, we're integrating into a system, what opportunities are around mechanical integration considerations, i.e., what can we incorporate as part of the sensor to better integrate in your machine or integrate into your process. So oftentimes customers will have us specify, or we'll work together to develop and specify additional hardware, maybe that attaches to the end that then interacts with the machine. So, and then the environment. Environment can be much more than just moisture and temperature, but what about EMF considerations? What about pressure, potentially vacuum even, right? So what are the long-term or qualification aspects around some of those challenges? Those are things that we want to make sure that are discussed. And the calibration, most of our sensors for test and measurement, of course, come with a very specific and accurate calibration assigned to absolute units. But sometimes OEM use dictates relative measurements or in situ, in system calibration. So we can accommodate different calibration requirements. And the goal here is that our solution doesn't give a customer anything more than they need, or certainly doesn't give them anything less than they need. So these are just a few questions that want to be discussed. But it goes back to, what are you trying to solve first? What's the problem statement, and what is the really the best way to tackle that? Next. Additionally, through the initial engagement on projects, there'll be some other considerations. What does a solution path look like? Are we going to be using a standard off-the-shelf product? Are we going to be customizing that? Or is this going to be a complete clean sheet design? So we can approach it differently depending on that. I referred to this earlier. What does the measurement package look like? Is it just going to be the sensor, or is it going to incorporate maybe some mechanical features, or even onboard or integrated signal conditioning? Do you want digital output straight from that sensor? We are glad to accommodate simplification, repeatability improvements, and also ease of assembly. So we've looked at and have supported all different options in that arena. So again, think outside just the sensor. What else can we package in there? Use requirements, is this going to be, again, a new product design, or is this an existing retrofit that we may introduce some design constraints? Typically, it's on the physical side, but also IP proprietary specifications. We certainly can work around those or manage those through the process. The commercial program. What is the overall schedule? What is the price point? What is the ramp-up rate? That's especially critical to be able to support OEM business, not only in terms of getting the prototypes out on schedule, handling the approval process, but then being able to ensure we have everything else in the supply chain geared up to support the longer-term production ramp. Are there special certifications? Again, PPAP, FAI, quality requirements, sort of other certifications might be more intrinsic safety requirements, things of that nature. But on the quality front, we can certainly accommodate and often do various quality requirements, again, whether it's part of the approval certification efforts or on-site audits supporting your entire quality team. It's part of partnering, and we certainly introduce our quality team to customers to ensure we have good communication channel there too long-term. Next slide. All right, I think it's going back to you, Randy.
All right, thanks, Brian. So yes, here I'll go over the our OEM processes, the 4 phases: design, test, build, and supply. The design phase, obviously, we start off with the drawings, getting those things generated, reviewing those with the customers, making sure that we're hitting all those specifications. Engineering support is we're definitely supported by engineering in this this important phase of the process. We're reviewing the configurations, different options that that we need to basically incorporate on the particular solution. The material requirements, we want to make sure that we're designing in materials that are readily available and or that meet the all the special performance specifications as far as output performance and that such. We'll be hitting up prototypes at this in the design phase as well, so we can do some internal testing, and or the customer can do some internal testing, basically proving some of the design aspects. And obviously the validation requirements. Once we get here to the end of that design process, then yeah, we're trying to validate everything that we've combined and put together on this process. And then we do a price buildup on it, so we understand obviously what the initial investment is from prototyping is going to be, along with what are the volumes and what those price points are going to be at that point in the game. And then obviously at the end of that design phase, we're doing our design review. So this is where we're going over everything. And that's, once again, one of the key things with partnering with the customer. So we get this everything communicated at this stage of the game. So we obviously want to design for efficient production processes. Okay, next, the test phase. So here's where we'll actually build up the prototypes, and then we can kind of basically validate the performance of the part, the producibility of the part, and even out to the end as far as how we're going to package this thing, getting it to the customer in the process. And then also we need to keep in mind the supplier selection at this point of the process, understanding if we need multiple suppliers on certain materials, and or understanding lead times and delivery aspects. Next, the build phase. So this is the fun part of it. So this is where we kind of dial in the process flow, the capacity plan, so we can basically be prepared. So this stuff should have all been communicated in the design phase. So we do know the prototype quantities, the prototype dates, timings on that. Most importantly, though, yeah, when is the customer's launch? When do the volumes? How do the volumes start? And to ensure that we do have the capacity planned for that to ensure a good kickoff. The floor plan, yeah, depending on the sensors and what we're doing, and especially trying to design for manufacturability, we go through and the team works together to obviously set up the machines accordingly, try to implement any sort of automation that we can into the process. This is where we finalize our process instructions. So all of the assemblers and the techs, they've got clear instructions on how to produce the parts. Our inventory plan is in place at this phase, once again, to ensure good delivery times. And obviously getting this incorporated into our MRP parameters to basically just, yeah, to make sure that everything is in there moving along. When the PO comes in, it's processed and everything is lined up accordingly and started off. Okay. And the very final part of it is supply. Inventory management programs. We work with our suppliers, but also we can do the high level supply chain management with our customer base. We can get very creative here. We're not limited. We do have obviously a lot of opportunities to set up the blanket purchase orders, Kanban system. Safety stock is another important factor. That stuff, once again, should be communicated with our new product introduction process, so we understand what that safety stock needs to be, and we build towards that. And forecasting obviously needs to be communicated continuously for obviously success, for being prepared for all this. And then obviously the supply chain management is most importantly for managing the delivery times to meet the customer's expectations. Okay, next. Common sensors used in these OEM applications.
I'll handle these, Randy.
Okay.
All right, so OEM solutions can come from really anything in our product portfolio. It could start as, again, sometimes we're not involved in the front end, but oftentimes we can look at our entire product portfolio, figure out what the best fit is, or again, to go custom. Mostly going to be around more of our mini line, smaller sensors. Multi-axis is growing, however, substantially. And load pins also growing area for us. So I'm going to spend a few minutes to go through just some of the more common particular sensors that, again, these are just kind of flavors, I would say, that we typically use for different solutions. Touch on some of the highlights and also the markets that we see them in. Next slide, please. All right, so MBS parallelogram. This is a very popular sensor in medical and some robotics as well. It's lightweight aluminum, good performance. Good load introduction point for good linearity and hysteresis. Typically lower capacities starting just over 2 pounds up to 100-pound force. So smaller capacity there, but we do a lot of load introduction customization around this part for various customers. Next. MVP, probably the most popular OEM-based product family that we have in our portfolio. Standard MB is easy to integrate, easy to mount, good cantilever design, good performance, especially for the price points of great value. And then the MVP, same form factor, basically brings overload protection. So these are real popular for hanging weight type measurements. Again, you can assume they're going to be used in medical applications. So a very good go-to sensor, again, if you need lower force measurement. Next slide, please. Taking the MB product family one step further is MBI. So this has overload protection like the MVP, but also adds eccentric load or moment compensation, if you want to think of it that way, similar to an SPI style load cell. So very repeatable results, is not as sensitive to where the load introduction occurs, but yet very robust in terms of repeatable, high-performing measurements. Also, again, very popular in medical applications and also limited more to lower force ranges. Next. SSB, continuing the cantilever beam family. This is a sealed version and it goes up to much higher capacities. So again, easy to integrate, bolt on one side, introduce load on the other. Often also incorporating different mechanical load introduction details on the live end of the load cell there. But it's robust and also a good value, good performance value, and can accommodate a wide range of loads. Next slide. SML, this is a very popular load cell given its small size. It integrates very well. You're talking 3/4 inch height, and even at the higher capacities, you're still under an inch. And in that small form factor, you do get high overload protection for the lower capacities. I think it scales from 10 to 5 times, depending on the capacity. But just a good general fit, general use. We see it in everything from material testing to some light material testing to general force monitoring inside machines, automation, and medical as well. So good go-to. And we offer, again, many different flavors of this product over the years. Next slide. 2400, this is going to be a little bit larger offering, but moving to a pancake style. But this is very rugged from its stainless steel welded, sealed standpoint. Great pick for heavy equipment machines, or they might be used outdoors or exposed to harsher chemicals. So the 2400 series also adaptable in many different configurations or amplification requirements, different signal conditioning, etc. So a good go-to if you need something a little more rugged. Next. WMC, this is growing in popularity quite a bit in recent years. Able to get very good performance out of a very small form factor. These are less than an inch in height. Usually the bodies are 1/2 inch to 3/4 of an inch, even up to, I think, the 10K range. So they stay very small, very easy to integrate with the male studs on both ends, and they are sealed. So given the small size, we've again done many different variations of these with a lot of customization options around them. Popular in medical, industrial, and also material testing. So very versatile. Next. Convex BT. We launched this a couple of years ago. This was the interface's take on the classic load button load cell, which usually has some compromises around it. We've gone to great lengths to improve repeatability and the eccentric load rejection. So much better repeatability than you typically see from something of this product family. Very, very small, or sub-inch type dimensions, depending on the capacity. Very low height. So very popular in machines where you don't have a lot of room. And also specifically, we see good use around chip manufacturing in that market in particular. And unlike most products on the market, they do come with multi-point cals for the standard product. But of course, we often custom tailor these even with onboard instrumentation, excuse me, not onboard, but inline instrumentation or specific cal data loaded in with each unit. Next. SMTM micros is a very small form factor S cell, essentially, 3/4 of an inch. So again, very small, but you get good performance, capacities, decent range up to 50 pounds force. There's overload protection as well on this unit, becoming very popular in robotics as well as some medical applications. So SMTM, very high performing, very small sensor, very easy to package. Again, female threaded holes, top, bottom, and with a slim thickness also helps in being able to get it into existing designs. Next. ULC. This is similar to the SMT approach, but this is more of a parallelogram, larger size. We would put this load cell up against pretty much anything out there in the market globally from a performance standpoint. Very, very repeatable. Again, a bit limited use given the lower capacity, but if you do have lower force or you're looking to very carefully monitor system aspects in a machine and look for small deviations, this is a great go-to. So we have been building this for quite a while, and again, we have many different OEM customers with unique takes on this product, and it's proven to be very, very reliable. Next. This is a multi-axis sensor, 3-axis, so you get FZ and then the XY loads. This is an example of something designed specifically for robotics. Very small flange pattern, compact design, but this is just an example of what we can do from a multi-axis standpoint. More and more robotics are looking for not only improved accuracy, but also more data as part of that. Next. MRTP, this is a great example of the ability to deliver again on the very low force range. This is a 0.2 Newton meter. Some robotics, if you have proper load isolation, but very good for, again, detecting minute changes with various systems or processes. Randy talked about just the advancement in smart automation, smart factories. Thus, what may have been done either with periodic checks or with, say, current monitoring of motors, direct force measurement is really taking things to a whole new level and bringing resolution to processes that weren't there before. So this is a good one to highlight for that reason. Next. And this is an example of the dedicated resources we have in our OEM efforts. We're developing a new line of Oem Specific Sensors. What does it mean, Oem Specific? Well, they're very small form factor, very rugged. Obviously should arrive at a lower price point, and as well as offer good scalability. So we're pretty excited about the Super ST. It's going to have a few different capacities here, and we should be having this roll out or available, I should say, for OEM customers here shortly. So, all right. Randy, I hand it back to you for trends.
All right, trends in embedding sensors in products. Next. So yeah, basically, Brian mentioned smart manufacturing. Industry 4.0 is the one of the newest trends out there, if you will. Basically, just automating the manufacturing floors. Yeah, it's just crazy what everyone's doing out there with communication and all the different sensors in there, trying to be as efficient as possible. And the more efficient they get, they just have to continually monitor that efficiency and improve that efficiency. So yeah, it's you'll definitely see a lot of our sensors used in those type of applications. Miniaturization, Brian mentioned the our Super ST, smaller to be able to basically get these things into into more applications, and almost taking a halfway standard part in the getting it converted into some of the higher volume applications. Different communication protocols. We've got wireless, there's Bluetooth, but on the automation or on the manufacturing floors, there's a ton of different types of communication protocols out there. So we have the ability to adapt to those. Advancing machine operation or interaction. So basically improving feedback, extending service life, basically monitoring tools, utilizing sensor technologies. Internal system health monitoring and remote monitoring. All these things are basically just relating to improving the efficiencies. Wearables, it's a new up and coming technology that we're seeing out there, obviously with robotics and all that stuff. But wearables, I mean, they're embedding the sensors into clothing now, so materials, textiles. So we are interfaces looking at all the different technologies out there. So we are familiar with these and looking at that, always looking at 3 to 5 to 10 years down the road, what we're doing, what we need to be doing. So next. And converting existing system components into force measurement devices. So we mentioned this a little bit earlier. If you can't get a load cell in there, or if it's just a customized, design or application, then we do have the ability to do, direct gauging. We can take a component, we can transducerize it, if you will. We can remove it from the system as a passive component, and we can instrument it with resistive strain gauges or strain gauges. We're not limited there. We can also incorporate other types of sensors into, customized solutions. Calibration to correlate bridge signal to system force or process. Brian mentioned earlier that we can do some, not necessarily just customers aren't necessarily just looking for a calibrated output, but they can actually just do the in situ calibrations in their process. We're not actually looking for specific direct output at a certain force, but basically be able to utilize that force feedback, if you will, to communicate to their systems. Simple integration that minimizes redesign. So as the customers are designing their products, their machines, the more feedback that they've got and monitoring that over time, data collection, they obviously are be able to redesign or design these devices to be as efficient as possible, eliminating redesigns. Great for monitoring changes rather than absolute force values. Yeah, that's once again, so not necessarily using that calibrated output, but utilizing that force feedback to sensing different types of situations. And they can be used to measure and monitor non-force events, non-contact, pressure, deflection, and more. Next. So the future is now. Obviously, Internet of Things, we've that's been out there for years, but it's here now, and with the smart factories, the different communication protocols and stuff that's going on out there, multi-systems communications, increased automation. The more they automate, the more there's a need for automation, automating the automated. So wearables we talked about, agriculture and efficiencies, vertical farming. So yes, the farmers are obviously getting more efficient on understanding what their equipment that they're pulling or working with, how that's working, how it's wearing. Vertical farming, yeah, that's a whole nother market. They're basically automating farming, if you will. So our automotive trends in automotive with the autonomous vehicles, braking, different sensing applications in there, weighing. We're seeing a lot of that. Aerospace and space exploration. aerospace, just from a manufacturing standpoint, automating, the equipment in the manufacturing process, and, space exploration. 10 years ago, we couldn't even fathom the thought of, launching rockets and relanding them. Obviously now they're, getting to the point where they're not doing that just for launch efficiencies anymore. They're obviously doing that to learn, to figure out how to do this um, on external planets, obviously in the future. So, and obviously innovating products. Everybody is trying to make their stuff more efficient, smarter, last longer. So next.
All right. I'll take it from here. Thanks, Randy. We've touched on a lot of the different industries, a lot of the different markets. We're just seeing more and more integration. It's not just machines. Sometimes it's elements used to calibrate or check the equipment. But even like the last bullet point, infrastructure projects, we're OEM to us is not just going into a product. It could be going into a structure. It could be going into project-based products, if you will. So we'll touch on a few application notes just to give some highlights to potential uses. Again, we typically are respectful of our OEM customers, so this will be a higher level. But Jamie, if you want to go ahead and move on to the first example. So we talked about medical, in this case, prosthetic limbs. Randy mentioned wearables earlier, and wearables are not just clothing, but it's prosthetics, it's exoskeleton would be the best way to summarize wearable developments. But prosthetic limb here is an example of utilizing a 3-axis sensor to be able to get not only the axial load, but any off-axis fore or aft shifting. This can be done not only just for R&D, but we're seeing it being directly embedded as well, especially with some of the smart prosthetics that interact electrically with the wearer. So this is one example here. Next. Robotics, logical application. However, we're seeing a very big shift in increasing demands for accuracy. Historically, robotic sensing has been more around contact or interference-based detection. And with the developments and improvements in multi-axis accuracy, we're now able to offer significant improvements to process or allow robotics to be used for processes that normally would not be considered for that. This is an example here shown with a off-the-shelf signal conditioning. But the reality is we do a lot of instrumentation packaging in other form factors to integrate directly with customers' product. So again, the takeaway here is we've got 3 6-axis capabilities and not only off-the-shelf instrumentation, but customer-specific digital protocol to be able to communicate with the rest of their system. So that's something that's growing for us. Next. Drones. Drones are being used for nearly everything these days, but with the advent of delivery drones, brought about the need to carefully monitor not only total payload, but also the distribution of that payload. So we've got a few situations where, in this case, WMCs were adapted, modified to work directly on board for flight, real-time flight monitoring. So again, machine integration or packaging for sensing is showing up everywhere. Next. You want to take this one, Randy?
Yeah, from the fitness equipment standpoint. So there are multiple sensors that are used in here, and I don't know if any of you have been to the gym lately. It's just crazy on the apps that they've got out there for monitoring. So typical ones on this particular scenario, we've got the basically the force or the weights being fed back to a display, but also these things are used for monitoring health, making sure you're not overexerting or causing damage. So it's not only just fitness equipment, but also physical therapy applications as well. Basically, seeing how a patient is progressing. So here on these ones, we've got load cells on different types of fitness equipment, and located on either load pins in pulley assemblies or actually load cells in in the press plates, the force plates. You can use tension cable devices to measure the force, the feedback. Okay. Pumps. So basically we're utilizing our torque transducers to basically monitor the efficiency of the pump in this particular application. A nationally renowned race team is using a bench to measure the fuel pump performance. So other type of applications, obviously the pump industry is absolutely huge, and so we're utilizing our rotary and or reactive torque sensors in those particular applications. Medical bag weighing. I think we've mentioned this. Fluid monitoring. Bag weights. You see these when you're donating blood. The bags weighing, or on the IVs. From those stands. It's just basically utilizing MB miniature load cells in this particular situation, or more importantly MBPs if it's a lower capacities. It's got that overload protection in there, but basically, monitoring those medical bags and providing feedback to the doctors for basically bags being full or empty, or I think utilizing other types of sensors like load buttons, things like that, monitoring the fluid flow without being invasive into the actual material that's being flown. Okay. Surgical robots. This basically a huge industry, growing industry. There's over a dozen companies out there today, producing different types of programs or surgical robots, if you will. So utilizing here force sensors for the haptic feedback, during surgery, so that the doctors can actually feel what the robotic arm is feeling and sensing. Next. All right. Top 10 frequently asked questions. Do we need to recalibrate our sensors?
Want me to answer that? All right, Randy. Well, recalibration is going to be up to the application a bit, and also customer requirements. From an OEM standpoint, of course, it really becomes more often a matter of on the front end doing good characterization work to understand the expected life of the sensor, but then also maybe incorporating an in situ check from an operation of the machine. How consistent is it working? How is that sensor working in the machine over time? So periodically, customers will want to integrate additional sensing capabilities to do an in situ cal. So it's case by case, but we can certainly arm tools for that.
Very good. What is the longest use time for a sensor?
Well, sensors get better with age, as long as they're designed in and used properly. So most of the time, our sensors are going to be designed for the life of the equipment. We can work with engineering teams to ensure that can be met.
All right. Can you provide certifications for quality inspection?
Sure. We mentioned earlier, of course, that we can provide PPAP, FAI. We can work with you on those requirements. Certainly work with your quality team if there needs to be internal qualification efforts of interface. We do that often. And of course, we can provide customer-specific calibration certificates if that's needed, either for a component level or from system level standpoint.
Very good. Thanks, Brian. Can you store our products for quick shipments?
Sure. We touched on that a few times as well. We can do safety stock. We can do Kanban. We'll work with you to understand what are your delivery requirements going to be.
Very good. Can you embed the sensor into a component for us?
Yes, we can directly gauge a component. We typically prefer to integrate a separate load sensing component just because, or a load sensor, simply put, just because it's typically easier to interchange and lead times are typically much better to manage. But if the situation arises where we need to directly gauge or turn some part of your machine into a sensor, we certainly can.
can we get exclusive use rights to the design?
Yeah, our designs are customer specific, of course, and that is only for those particular customers to use.
And obviously, that's part of that whole partnering and early communications as well, right? Get that stuff discussed and understood right from the get-go. So,
Yeah, and that also includes private labeling. I don't think we mentioned that thus far, but we do a lot of private labeling. So,
yes. Is there a cost for engineering or design services?
well, there is a cost, but case by case, we'll be able to determine best path forward. If it's strictly design services or rather NRE for development of the product, typically we absorb that through the program and can work with you, or customers, what's the best fit for the program.
Yeah, absolutely. What is the process to request a repair?
Repair is going to be handled through our service group. We've got a well-established RMA process. We can, again, work with you to ensure quick turns if necessary, send units out as needed, even before we may get your suspect component back. So we can certainly work with you in that regard.
Can we perform our own calibrations?
Absolutely. We can give you the tools to either do in situ system level cals or health checks, if you will, of the sensing element, or we can set you up with turnkey calibration equipment, much like we use here at our factory.
With software included as well. Yep, good stuff. And the last one is here. What is the minimum volume for an OEM product?
Well, it starts with one, but we're scaled up to handle everything from 1,000 to 50,000 pieces a year. We feel that's been historically a good sweet spot for us, but we have the resources and commitment to be able to scale and handle that.
All right. Do's and don'ts. Just we'll go through these real quick and then open it up for questions. So don't wait. Yep, we obviously want to be involved on the front end of the opportunity of the situation. So do engage in concepts. So we can be creative. So think outside the box. We're definitely capable of reacting and designing to meet your requirements. Do know what you want to measure. So as Brian mentioned earlier, that's obviously in the getting started phase, extremely important on that standpoint, especially with we also mentioned about calibrations. You know, typically a standard lid cell comes with a calibration certificate, and that's what's used basically for for incorporating into your system. But you can do the in situ calibrations and utilize these things for different feedback. Do know your material requirements. Obviously, once again, one of the most important upfront items to be covered. Our MPI process, we're asking those questions on the front end. Do not exclude cabling and power requirements. Yeah, that's a good one. Cables, we've got we do manufacture our cables in-house and power requirements. So we are capable of supporting you guys on all of that, especially with our customization abilities. Do know certification and quality requirements. I think Brian had touched base on that as well earlier. That we can adapt to the customer's requirements there from a quality or certification standpoint, and that's all once again communicated on the front end, so we don't get caught later down the line without that being addressed. And do prototype. Obviously, prototypes they answer a lot of questions for the solution for the application right in the early stages. And do know your timeline from start to launch. We also mentioned that before. So just kind of summarizing the importance of what we've learned, our best practices in the OEM process. Resources, just to go through these real quick. Our website, the marketing team has done a tremendous job. So we've got a white paper that you can link to here actually on this presentation that will be out there. It's on Oem Solutions, solutions overview for Oem opportunities, applications. You can contact our Oem experts right via the website. If you're in any of these documents, then you can reach out to us, ask us a question, or give us the details of your opportunity, and it'll come immediately to us, to our team. OEM application notes. Yeah, we've got I don't know how many pages of different notes out there on that, and I think we're adding those things on a regular weekly basis. Free product design files. Yes, we obviously provide that information. We've got that available. Our sales process, our inside salespeople aren't inside sales; they are applications engineers. So when you're calling in, I mean, you're actually talking to engineers. So we've obviously found this very successful to supporting and answering all the questions out there. And then once again, we've got the Oem Solutions team, dedicated team to assist and support you guys throughout the process.
So I think here's where we'll start to open up some questions. We have a couple already. I want to just let you know that if you use the chat feature, we're able to actually go through and see your questions. If you're not able to unmute the mic, sometimes it works for people, other times it doesn't. But let's start off. Paulo has a question. He wants to know, has Enterprise ever tried to monitor force on CNC machines to check for the wear of a cutting tool?
Yeah, there's certainly been applications where customers are looking at the spindle loads, whether it's the vertical drilling or bending/shear loads. That's obviously a critical component for machine durability. Also, applications around tool holding forces and what is being, or excuse me, I guess it'd be tooling, holding the tooling maybe on the support side and what's happening and any changes in the process there. So there's certainly opportunities on both the active as well as the supporting side of machining.
And Earl had a question early on about a couple of points he wanted to expand upon. Earl, we went pretty fast through all of that, so if you have any more detail that you'd like to answer, please use the chat feature to address any questions. One of the things that we commonly are asked, in addition to the frequently asked questions, is what is the average length of time that you start from early design to actually getting products in hands for machines? Can you give us a kind of a life cycle timeline of what you've seen?
Sure. It's going to vary. Sometimes we are up against deadlines. Usually those are the situations where we may not have been involved in earlier discussions. But that said, we have capabilities, dedicated capabilities to tool up and deliver prototypes in a matter of weeks in some cases. So, of course, earlier and better increased visibility is preferred. But as Randy mentioned, we do have dedicated assembly, manufacturing, and even some machining capabilities to be able to get things quick turn.
That sounds great. Another question we often get is, as you talked about, making a component active, an active sensor for feedback. How often is it that people want to have custom strain gauges actually utilized in those products versus utilizing a load cell or an existing product that we customize?
It's definitely not as common. Off-the-shelf sensors are typically the better approach long term. We can better control the entire process and, of course, ensure better repeatability from component to component. When you start gauging, or excuse me, from machine to machine or sensor to sensor, when you start gauging individual components, then it becomes a matter of what's the characterization work that's done on it. So it's not as common, but it certainly can be done.
And I know you guys had talked briefly about environmental considerations. I mean, we see stuff, submersible requirements, sealed requirements, temperature requirements, far below freezing all the way up to extreme heat. What are the capabilities around those types of sensors?
Well, we have in-house testing, of course, to be able to do extreme temperature, both cold and hot, and we can develop solutions and validate solution designs within those conditions. We also have the ability to perform pressure testing for some products that may be subjected to high pressure loads. Vacuum is not currently in-house, but we have done many vacuum-related products and support not only from a design standpoint, but being able to ensure performance and life in those situations.
We've got another question. How often should the sensors be calibrated?
I think I answered that one, Jamie. That was one of the first ones, but it depends. Again, OEM is a little different than standard test and measurement, where we would strongly recommend regular cal intervals. But on the OEM front, when it's installed in a machine, typically it becomes a matter of, I would say, front end machine level validation to see how does that sensor change potentially, or more importantly, the things around the sensor over time. So typically you can get away with in situ checks of the machine to validate the calibration of the sensor rather than having to disassemble and pull the sensor out and do a component level calibration. Intervals, it's tough for me to give a firm answer, but the goal, of course, would be to design something that should last potentially the life of the product without needing a detailed level recalibration.
Thanks, Brian. Again, if you have any questions, be sure to put them in the frequently asked question. We will be posting this presentation online for future reference. And of course, our team is always here to ask and answer additional questions for you. One other question that seems to come up on a frequent basis is just trying to ensure the supply management side. You guys have touched on that, but will you actually house parts and wait for calls on those parts?
You're saying if we'll stock? Yes, we'll
Yeah.
establish safety stock and ensure we have units ready on the shelf.
Good to know. All right, I have one more question. Instrumentation. We're going to have an advanced instrumentation webinar on March 17th. Just got that plug in. But I wanted to know, what type of instrumentation do you frequently get asked about when when you're looking at these types of designs? Is that something that we can also play a part in?
Actually, yeah, it's a great segue into the next webinar, just in that around OEM in particular. Much more often, it's a win-win not only for us, but the customer to take the signal conditioning on board with the sensor. Essentially, what you can get is more repeatable standardized outputs. It's plug and play on the machine side. Don't necessarily need to go in and do any sort of calibration system level after you install the sensor. So we're seeing integrated digital as becoming an increasing trend. And as Randy mentioned, obviously a lot of different protocols that go around that, but we're geared up to support any and all.
Including wireless. Assuming these products are installed or placed in remote locations, wireless is also available?
Yep, absolutely. We've done quite a few smart factories where we have to scale many wireless signals and get those all communicating through maybe various access points on the receiving side and get those all communicating together. So again, system level approach.
Awesome. Well, thank you all for joining today. Randy, Brian, great presentations. Thanks for telling us more about the OEM solutions that Interface has to offer. Of course, we look forward to hearing from those that have interest in exploring new ideas. We're here to innovate with you. Thanks for taking the time today. Again, this will be posted online. We'll send you a follow-up communication along with an invite to our next webinar on March 17th. Take care, everyone.